D odds, the solutions. So I'm starting with the first half of the video with the ones that you were supposed to do for your homework. So you're supposed to go ahead and fast forward through those as far as the ones that you need to do for the homework, those corrections, and then do the ones that in class problems, hopefully learning, making corrections while you're going through the video, and then watch the second half of the video after you attempt the second half of the problems. Okay, let's go ahead and get started. Starting with number 3. That was a homework problem. A random sample of 500 adults. And large city, and I have 304 adults. And the sample of unemployment with great concern, the standard error. What is the standard error? So the standard error formula, if you look on your formula chart, is p hat 1 minus p hat over n. And that's a one sample mean formula chart. My p hat is equal to 304 over 500, which is about equal to 0.61%. So you can see that A is the only one that, and then of course 1 minus p hat is 0.39. And this is the only one that satisfies the problem because I've got 500 here as my n, and the rest of them don't. Okay, so let's jump to number 7. This says I've got statements, I've got the intervals here. I've got Sue and Javier estimating the intervals of a portion of students who have a pet dog. Got a random sample of 81 students from the 2,400 students. So that's a random sample here of 81 from the 2,400 students at their school. And Javier selects the random sample of 64 students. They will both construct a 90% confidence interval and consider this situation the sample proportion. Sue's sample is equal to the sample of Javier's proportion. Which of the following statements describes their interval? Okay, so I'm going to be, because hers is 81 and Javier is 64. It's looking here, I'm just kind of looking at, these are talking width. This says greater degree of confidence, that they both are 90%, so we definitely know that's not right. And the rest of them look like I'm asking for width. So I know that, remember, that I just did is that my formula for standard deviation, remember, my width is going to be how big my standard deviation is, because standard deviation, remember, is average distance from the mean. So my standard deviation is equal to p hat 1 minus p hat over n. And you can see my n here is 81. So when I divide by a bigger number, I'm going to get a smaller results. So that's why I know that Sue is going to have a skinnier, because it's going to be smaller, right? Smaller with it as 81 versus 64. So that's how I knew that it was going to be E. 11, a recent survey indicated that 73% of the respondents try to include locally grown food in their diets, and 95% confidence interval for the proportion in the country who try to grow foods in the diets is given as this. Okay, so I noticed right away 73% is in the interval. So let's say this says assume all conditions for inference were met. Okay, based on a confidence interval, which of the following is the claims is supported? So it is in the interval. So we want to make sure we understand that. It's a 95% confidence interval. And so this one says less than half the people in the country try to include locally grown foods in their diet. Well, that's not true, because that would be 50%. And we can see our confidence interval is definitely from 70 to 76%. Less than 70% of the people try to include, and that's not true, because again, our confidence interval is from 70 to 76%. Less than 75% of all people in the country try to include, and that's not necessarily true, because this goes from 70 to 76%. And then it says less than 80%. Well, this one makes sense, because the highest that my interval goes to is 76%, so that's true. And this one says at least 95% try to include, and that's not true. I did a 95% confidence interval, but what I'm trying to interpret is my interval. All right, so that's A. Now let's jump to B. So B, number 3, a workers representative for a large factory believes that more than half the workers at the factory want the opportunity to work more overtime hours. Which of the following is true for the hypothesis to belief? Okay, so for the first of all, for here, we are going to immediately cross out anything here, p hat, p hat, p hat. See all those? Those are not right. Remember, my hoe, if you go ahead and look at your cheat sheet on your calculator, you'll see it says p equals. We have a hoe mu equals when I'm doing mean. We have a hoe beta equals, right? So those are all the ones that we've learned, but it's always the parameter. Remember, the parameter is always the Greek letter, except with this case when I have a p and a p hat. So we definitely know these are not true. The next thing to look at is it's always hoe equals. So it looks like this is an equal sign and this is an equal sign, so that's good. The next thing to look at is those two things are going to be the same. That's what it is. So it looks like these hypotheses, without reading the question, are both good. Now we got to read the question, and you can see that this one says a worker's represented for large factor that more than half. And so that says more than half, so that's why it's E, because it's greater than. Number 7. Okay, this one's asking for the test statistic, and it looks like this is a, so it wants my T, or my Z for this because it's a proportion. So I have Z is equal to, I have 36 out of 150, which by the way, 36 out of 150 is 24%. Minus, because it's going to be, I'll go ahead and give you the formula, sorry, p hat minus p over square root of pq over n. If you look on your formula chart, that's where it's going to be, but this is what it's wanting, is just the formula. So p hat is 36 over 150 minus here, which is my p, 0.2 over square root of, and this one is always going to be here, 0.2, 0.8, and then it gives me my n at 150, right? Yeah. So that's where that is, and you can see that this one matches up. Okay, this one here is asking if the null hypothesis were true, which is the following statement is correct interpretation of the p-value. So for p-value interpretation, let me give you p-value interpretation. Is going to be, you always say if hoe is true, you have a p-value percentage of the time that my test statistic or my stat, whichever way we're doing, happens by chance, or more extreme. And if you look into your calculator, if you look under the vocab, p-value is in the vocab under the calculator, so you can check that out and see it, and you will see the definition here. So I'm going to look here and see why it looks like I have a p-value here. So it looks like all of them start out the same. Of all possible samples, the same size. So that's starting out all the same. So those, but then this is say, this is just will result of a success of this or less, this or more. And then, okay, so we know that 93.6% is that is my statistic. So that's what I'm going to be using. Remember, that's right here. That's the part 3. So we definitely know that these are not right. Or wait, this could be right because I'm just looking at. Okay. So then now we say, well, what are we looking for? It's looking for, remember, that or more extreme. So it says we have the investigator's random sample of chicks that find that Hedrick has a success rate of 93.6 with a p-value of this here. Remember, we have the p-value is have the sample portion is the direction of the beliefs, and it's telling you that it's less, and that's why it's less. Because it tells you here the hatcheries claim the workers are 95% of the time believes the workers' success rate or workers are correct is actually less than. So I'm having, if I were to write this out, it would be hoe, and it would be p is equal to 0.95, ha, p is less than 0.95. So that would be in my hypothesis. And if I were to put this here, it'd be like this. And then this here is 0.936, and it's going to be like this. and that's my p-value, which is equal to 0.0322. So that's why it's that or less. So this one is correct. Okay, number 15 is the next one. Is the significance level of the hypothesis test equivalent to the probability that the null hypothesis is true? So the significance level of the hypothesis test. So the significance level of the hypothesis test is, let's say alpha equals 0.05. The probability of a type 1 error is 0.05 if this is true. So this would be if it is false. Or no, sorry. That would be if this is true and we rejected the hoe. So that's why it's no, it is not. Okay, so this is the significance level. This is not the same. What it's talking about is only if we reject hoe, and we shouldn't have, because that would be a type 1 error. Hoe is whatever we say, right? And if we say, okay, that's not true, and we're going to go with ha, remember the probability of that occurring, the probability of making the type 1 error is alpha. And we're like, oh, wait a minute, just kidding. That was wrong. We actually have to go with hoe. And that is what the significance level is, not the way it's describing it. This just is saying, is this a significance level of the hypothesis test equivalent to the probability that it's true? No, that's not the case. All right, and then this is part C. Which is the following is defined by significance level of a hypothesis test. So remember, that's kind of what I just talked about in the last one here. The probability of making a type 1 error is the significance level, so that's all it's asking for. It's kind of a goofy question, but that's just alpha, and alpha is the significance level. All right, and then number 7, a new drug to treat certain condition is being tested. The null hypothesis of the test is that the drug is not effective. That's the hoe. Hoe is that it's not effective. So basically, it's that that's the same as the other one. And then ha would be it would be effective. For researchers, the more consequential the error would be for the drug to be effective. So ha is that it's effective. And so, but the test does not detect the effect. Okay, so what it's wanting to do is it's really wanting to make sure that I fail to reject, right? And so we want, in order to do that, we would like the alpha to be higher because I don't want it with a p-value. I don't want to reject. For instance, if p-value is equal to 0.03 and alpha was p-value to be lower, or alpha significance will be lower, sorry. So if alpha is 0.05, that would reject. But remember, we're wanting to make sure that we don't reject. So really, I would want like the alpha to be lower at 0.01, so it would fail to reject. So the following to avoid the consequential error. If I increase the significance level, I'm going to, if I increase the significance level, I'm going to increase the probability of a type 1 error. Yes, because that's what I just said. Because if I make it higher, if I make it at 0.05, that is going to then cause this to be rejected, which would be, remember, the type 1 error is rejecting when I shouldn't. A random sample of 100 people from this county had 15 people with blue eyes. A separate random sample of 100 had 25 with blue eyes. So I have 15 out of 100, and I have 25 out of 100. So that's going to be P1 hat and P2 hat. Okay. Assuming all conditions are met, which of the following is a 95% interval to estimate the difference of the populations in Blue Eyes Country S minus. So I'm just going to have you guys put this into a 2-prop Z interval in your calculator. So it wants 95%. Let me bring my calculator up. And you're going to go menu, stat, interval, 2-prop Z interval. And we had, if I remember right, 15 out of 100. And I had 25 out of 100. And I believe it asked for a 95%. Let me just double check. Yes, it did. And I hit OK. And there we go. My confidence intervals right here, negative 0.21 to positive 0.01. So I got negative 0.21 to positive 0.01, and that is indeed what we got here. Okay, and the last part, D. Okay, number 3. 90% confidence interval constructed to estimate the difference of proportions between two populations proportions. Which of the following is the best interpretation of what is meant by 90% confident? Okay, whenever it says probability, you say, ooh, it's not probability. So you see that probability. This here, you're going to say, let's see, you want repeated random samples. We like this from populations with the samples the same size. So you like that. You like this. Those are good. Approximately 90% you like that. Of the confidence intervals constructed will have the true difference of population. This, the problem says, let me show you what the problem is on this one, of the sample proportions. Remember, you're looking, the confidence interval is all made from my sample, right? That's all what they're made from. You're looking, is the population, you're asking is the population of the sample, and that's what the answer says. But this part here that I marked in green, right here, I should have marked it in red because, it's wrong, and green is right, seems to be right? So there we go. So it's the sample portion is the problem. This here, letter C, if the sampling process is 10 times 10, will capture. So will capture on here is too deterministic. We're not sure. It could. It potentially will. We think it's going to be about in the long run, but not necessarily. This is too deterministic. And then again, this one here, and I know this says here will capture because this is approximately 90% will capture, and that's okay. This one doesn't say approximately 90%, it just says it will. So just make sure that you see the difference. This one here is the same so far of the confidence interval will capture, and then this is the problem for this one. Will capture what? The sample. So it's not capturing the sample, it's capturing the population. So make sure you see that. A yearbook company was investigating whether there's a significant difference between two states in the percent of high school students who ordered the yearbook. From a random sample of 150 people, the students selected one state. 70 had ordered a yearbook. From a random sample of 100, 65 had. So I have 70 over 150, and I have 65 over 100. Which of the following is the most appropriate method for analyzing the results? Okay, well, you can see that I have two proportions immediately. So definitely it's not one sample. And then I have this one says sample proportion. So that's the problem. It's never the sample proportion. It's always the population. And then this just says a two sample z-test for population proportion. But I need to make sure, obviously, it's the difference. So here, I'm going to just kind of go here because you're missing difference in population. (11) Have the conditions for statistical inference for testing a difference of population proportion been met? All right, so it's saying all have been met. So let's just kind of go through here and I'll help you making sure remember, we're going to have a random sample. We want that the independent, remember, is if it's without replacement, which I'll read through it and see if it is. Remember, we're using a 10% rule because we got to put it back. If that's, as long as you only use that if it's no replacement. And then the other one we're looking for is our large sample. And this one looks like it is it is proportion. So we are going to be using our NP hat and NQ hat greater than 10. So let's just kind of look through them and I'll mark them as we see them. Potato chip company has a large potato chip bags to investigate whether the new packaging will lower the proportion of bag damage. The company has a random sample. There we go. Got a random sample. So that's the first one. Of 150 bags from the old machine and found 15% were damaged and then selected a random sample. So it's a random sample because it looks like I'm doing two proportion. For the new bag and found 8% were damaged. So we have 15% and 8%. We're going to have to be using that. Let P hat 0O as the sample portion of bags in the old machine damaged and P hat N represent the sample portion of the new bags. So, and then PC hat is the combined. So it's going to combine them. So let's combine them. And if I combine them, I have 15% of the old one. And so that's going to be an 8% of the new one. And so because remember, we do have to find PC. So NPC hat and so for, I'm going to just write it over here for large, because I have a 2 prop, it's N1 PC hat greater than or equal to 10, N1 1 minus PC hat greater than or equal to 10, N2 PC hat greater than or equal to 10, and N2 1 minus PC hat greater than or equal to 10. Those are the 4 things we need to do. So you can see, actually, let's go ahead and it did it here for me. There's my PC hat, which is 11%, because it does, all right, it takes each one of them, 150 times 15% for the first one and 200 times 8% for the second one. It tells you how many that is going to be for each one of them. And then if you put them all together, so we have 150 times 11%, 150 times 1 minus 11%, and then another one, 200 times 11%, and 200 times 1 minus 11%, and all of these are greater than or equal to 10. So it makes it approximately normal. All right, so that's that one. And then we're also going to see that it's about 10 times more than the population, because you can just look at, and wait, hold on, Lincoln. So that was this one. If we did the large, and then this one here, when you just look at the size of the population, and you can do 10n greater than 10 times 150 is less than, of course, all, and then 10 times 200 is also less than or equal to all of the bags that were damaged. Okay, 15 is the last one for this, and then you're going to go to the next section. Which of the following is the correct interpretation of p-value? Again, the p-value, remember, if HO is true, you have a p-value percent that your test statistic or your statistic or whatever that your value or more extreme happens by chance. So that's what we're looking for. This one, the probability of selecting students is 7%, but this one doesn't talk about HO being true. Let's look at the students who drive to school are the same, because HO starts out as this, P1 is equal to P2, E is equal to the same, right? So this one says is greater than, look at this. So let's mark, I'm going to mark it red of what's wrong, is greater than, so that's the problem. If the proportion who drive to school is greater than, this did the same thing. This one says the same, so this one we're okay on, so I'm good with this. So drive the same. The probability of observing sample difference is, so this is the problem here, is I need the word at least or to more extreme, right? Because we said it's or more extreme, and that part here, or more extreme, is what it's missing. So that's why D is the answer. And yes, the p-value is also located on your the cheat sheet calculator. Okay, so this is it for the first part. So now stop the video. Do the other odds that you did, starting with number 1, and the every other odds that you did on the reassigned value or the reassigned assignment, and then turn the video back on and do your corrections. Okay, you should have done that too. So this is part 2 of the video. Part 2 of the video here is, which of the following is the most appropriate for the interval for the manager to use such an estimate? Well, this one here I have, it's the manager's looking for a proportion, and I have one proportion, and so therefore I'm going to be using 1 proportion Z. This one asks, is it appropriate to assume the sampling distribution of the sample is approximately normal? For normality, remember, I need NP greater than or equal to 10 and 1 minus P greater than or equal to 10. And you can see A town has an upgrade. I have 97 out of 100. So I have 97 out of 100. That one's going to be okay because I have 97 over 100 times 100 is obviously going to be 97, but the other one's going to be 3 over 100. So that's the problem, that is not bigger than 10. Which of the following is not a correct statement? Because I'm wanting a researcher to use a confidence interval to estimate the unknown population proportion P. So I want which one's incorrect, right? The endpoints in the interval can vary with each sample. Of course it can. Each sample is going to be a little bit different. Whether the interval captures P is not known with certainty. Exactly. That's why I'm only 95% confident, or 90. I'm not 100%. The population proportion is fixed, but the sample proportion can vary. That is true. The population proportion is one thing, and the sample, I can have different things from each sample. Interval does or does not capture P. That's right. There's no probability of 95%. It's either in it or it's not. B says the probability that P is in an interval. See, and that's the problem. We don't have probability. Confidence interval is not probability. Okay, next one, part B. The most appropriate for the investigating the sociologist's result, well, again, on this one, I have 75%, so that's a percent, so I know that it's going to be, and I have one sample that it's talking about. It's only having young adults in the country. It's not talking about two things, so not two, and it's never sample, and I don't have a difference when I have just one population. A one sample z-test for a population proportion will be conducted. Which of the following conditions checked the sampling distribution of the population is approximately normal? For the normality, remember, it's going to be large sample size. And so that's going to be this one here, only this one. Large sample size is what shows normality. With proportion, it's NP and Q. With means, it's N greater than 30, which that's not in this unit. You'll get to that on the next unit. Which of the following is the standard deviation to calculate the test statistic with a one sample z-test? So for Z, if you look at your formula chart, remember it is going to be, not just once the standard deviation. So for standard deviation, it's just going to be square root of P1 minus P over N. So it's got a couple things in here. So let me just read through it. It says in the United States, 36% of the people have blood A from a random sample. Now the random sample I'm going to mark in red because that is P hat is 66%, okay? And then it says consider a hypothesis to investigate whether people in Norway have blood type A positive different in the United States, which is the following standard deviation of a one sample z-test. Now for the one sample z-test, look, this is, the random sample is P hat. The P is equal to 36%. So that's why you want to use 36% on this, because that's not from a random sample, and my standard deviation is not from the random sample because my model is based on the population. Okay, is there convincing evidence at the 0.05 level that the true proportion of individuals whose competitor's card is actually greater than 0.65? Well, it gives me a p-value. The reason I'm marking it in red because the p-value is 0.053, and I'm asking for a significance level at 0.05. So 0.053 is greater than 0.05, so that would be a fail to reject, and it would be not statistically significant. So these say yes, so we know those are wrong. And this says because the sample proportion, because it has nothing to do with the sample proportion, it has to do completely with the p-value. Okay, next one, part C. The alternative hypothesis is the proportion of all washers produced the specified diameter is 90%, which of the following is a type 1 error. Okay, so a type 1 error is when I have HO and I reject it, but I shouldn't have rejected, but that was wrong because HO is true. So what you need to do is you need to find your HO. In this case, the HO is the P is equal to 0.9. And the HA is P is greater than 0.9. And so the type 1 error is the test. It's when I have convincing statistical evidence that proportion is greater than 90%, but the actual proportion is 90%. So when I did the test, I said, oh no, this is wrong and this is true. And then I go, wait a minute. Actually, that was true. Let's back up. So C describes that. If all other factors are held constant, which of the following results in to increase the probability of a type 2 error? Okay, to type 2 error, let me show you. Type 1, the probability of type 1 is alpha. Probability of type 2 is beta. As power increases, beta decreases. So as alpha goes up, beta goes down, and of course power goes up. Power, alpha, right? If you're alpha, okay, you power, all that stuff. When we draw it, let me just draw it here for you. Okay, so this would be like my P, and this is like my P hat. So if this is a really terrible drawing, sorry. This is my alpha right there. But then this is my beta. So that's beta, that's alpha. And then this is power. So you can see, let's pretend that alpha is going to go up. So I'm going to make alpha go up here. So now, of course, what happens here? That makes beta go down because beta now is going to be based off of here. But then that makes power go up. So let's say that again. As alpha goes up, power goes up, and beta goes down. And remember, alpha is type 1 error and beta is type 2 error. So alpha is significance level. So when it says for beta to go up, I believe what the question says, yes, as beta goes up, alpha is going to go down. Alpha is going down. Because significance level, that's another way of saying alpha. Which of the following is the most appropriate to create an estimate? Okay, so I have 40 engines and I have 14 failed, so 14 over 40 in P1 hat. And then I've got 30 engines. I got 9 that failed. I have P2 hat. So you can see a right ready. I have proportion. So proportion, right? But I've got 2 samples. So not that one, not that one. And I have to find for all my 2 samples, I am looking for a difference. And this says the wrong thing is that's wrong with this one. That's a sample, so that's wrong. And then this one is missing the word difference. So see that word there? That's what you're missing there. So that's wrong. Okay, so it says, which of the following conditions? Oh, this is large sample condition. So this is what I'm doing is this is the large sample size, and I want to make sure I check for normality. Yep. All right, finally, part D, last one. Which of the following is the best interpretation of the interval? All right, so if it says probability, immediately let's cross it out. So let's say, yep, probability. So no. If it's too deterministic, doesn't say approximately, we know that that's wrong. So I'm going to see, and then if it says it's in the sample, not in the population, if it's the population, then we know that's wrong. And if it's not a difference, we know that's wrong. So that's what we're going to be looking for. So this one, let's look at C. We're 95% confident that the population of all smokers with CVD. So this one says is greater than the proportion of non-smokers because the interval is positive values. No, it's not, though. It's definitely not more positive. Okay, more positive values, yes, but doesn't matter because remember, if there's a negative value at all, it's a difference. 0 is contained in that interval, so that doesn't matter. So that's why this one is wrong. A, let's look at we are 95% confident that the difference in proportion for smokers and non-smokers with CVD is the sample is in the sample between. But look, that's the problem, which I knew that's what they always do. Those are the main things that they always do. They'll tell you that, okay, they always use the word sample, and you know that's wrong. They always use the word probability, and you know that's wrong, joom, joom. And then they have something else thrown in here, like this one here, where like, okay, this is more positive than negative or something. This one says, does the confidence interval provide evidence that this is plausible? Well, I can see here there's no difference, so it's a, so I'm looking for that 0 is in the interval. So my HO, remember, is P1 equals to P2, or P1 minus P2 equals 0. And the HA is that it looks like that says that there's greater than, or I'm not sure that actually, does the convincing evidence provide that the belief is plausible that there is no difference in here? Well, no difference would mean that it's contained in here, and yes, 0 is contained in the interval, so absolutely no difference is exactly what it's saying. Okay, which of the following are correct, null, and alternative to test the new pesticides and fewer pumpkin plants eaten by bugs? The first thing I'm going to do is let's mark what's wrong and see P hat, P hat, P hat. Those are wrong. P hat, P hat, P hat, wrong. So it's not D and it's not E. Everything, oh, this is wrong because the HO is, here, let me mark exactly what's wrong. The HO needs to be an equal to, and the HA does not need to be an equal to. The HO is always something equals, and the HA is always less than, greater than, or not equal to. So that one's wrong. So these two are correct, and so now we have to just see everything's the same. We just have to look, is it not equal to, or is it greater than? And then it says we're looking to see if there's fewer pumpkins eaten by bugs, and that's bugs. So it could be PB less than PA. It's the same thing. Bugs less than the patch A. So that's why B's right. All right, so for this one, it looks like I've got a 2 sample z-test. We have P1 hat equals, I have 40 starfish, and we have 6 over 40. We have P2 hat is equal to 11 over 40. So I have to combine it. PC hat is 6 plus 11 over 40 plus 40. So I have 17 over 40. And so you're going to see, I'm going to put it over here, which is 6 plus 11 over, so 0.2125. There we go. And this one asks for my test statistics, so it's going to be Z equals P1 hat minus P2 hat over square root of PC hat 1 minus PC hat. Remember, PC stands for combined, and we're combining them because we're assuming that we know this, the HO is the same, so the proportions are the same, so therefore the standard deviations have to be the same, 1 minus PC hat. And this is in your formula chart, so make sure you check that out. So these all match up here. P1 hat here, it's right there. P2 hat here, it's there. And then, of course, PC, I just have mine distributed. So this is another way of writing it. So it's just taken, distributed into there. I have mine out. All right, and that's it. That's the correct one. I believe that is the last problem. Oh, no, but there's one more. All conditions for inference are met, resulting in the p-value is 0.12, which is the following is correct decision for the test. Okay, alpha is 0.01, so we know p-value is equal to 0.12, which is greater than 0.01, so we have a fail to reject HO. So this one, first of all, let's mark off some wrong one. This is less than alpha, p-value is not less than alpha, p-value is greater than alpha. So these all say greater than alpha. And the null hypothesis is, this says is rejected. No, we're failing to reject. We already said that. This is, so we know it's not these right away. And now we know it's between C and E. This says there is not convincing evidence, and there's not because we're failing to reject, so we don't have evidence to reject. The whole evidence aspect is to reject, so we go with C. All right, and that is it. I hope that helped, and whatever you don't finish in class, please do at home.